So, with probability, this is sort of the this is the pointy end of probability, I guess. And we're going to start with a few simple examples. And I want you to identify, I'm not going to tell you too much about this. I've got 4 rowers and I need to fill 2 positions. How many options do I have? So how many arrangements do I have for the rowers? So position 1 and position 2, how many arrangements do I have? Who thinks I've got 16? Who thinks I've got 4? 8? 12? Damn it. How do you get 12?
4 times 3.
How does that work? Because I can see some people in the room correctly confused. Why would that, how does that work?
There's 4 options for the first slot, and then the second slot, 1 person's used up, so it's 3 more.
Correct. So we've got 4 options for the first position. We can use 4 options for the first position, correct? Let's just go row A, B, C or D. Now one of those rowers is going to be in the first position, so how many do we have for the second position? 3 options. Does that make sense? So we can have A and B, A and C, A and D, B, you get the idea. Cool? Same question now, how do we do 6 rowers to fill 3 positions? I'll let you go with that. I'll give you 10 seconds to figure that one out. You don't need a calculator. What have you got, Arabelle? 120, how do you get it? 6 times 5 times 4. Who went about it in that way? Very, very good. So it is 120. So we've got 120 arrangements. Is that right? Yeah, good. Now we can probably already see that as we, like if I had a rugby league team, we're starting to get some pretty gross maths going on, correct? How many kids in a rugby league team? Well, depends on the level. Let's just say 17, let's go to the NRL, so you've got 17, 13 starters and 4 bench positions, correct? So if I've got 17 positions and say 60 kids to fill, we're dealing with some pretty gross numbers, correct? So box method's going to start falling down at that point in time. We need another method, another technique that works. This is exactly the same as the box method, it's just a little bit less intuitive. Permutations, who's seen that word before? Who has never seen that word before in their life? That was me when I was you, and I shudder at the thought of combinations and permutations every year. Who's seen this before? Why am I shouting N at you right now? N minus R in brackets. Why am I shouting those things at you? What does that mean? Factorial. So what is a factorial? N times n take 1, times n take 2, times n take 3, all the way down till 3, 2, 1. So that's a factorial. If you did math camp, you would have come across that when you had to find the number. Was it 17, I think? One of the numbers is impossible to find unless you, we might even do that one day, but not today. One of the numbers is impossible to do unless you put a factorial up your sleeve. Anyway, that's neither here nor there. The way this works is whatever, you will see this represented like so. Okay, so this is the question. I've got 11 people filling 7 positions. How many arrangements are there? That's how I would fill it out. So 11 represents the number of people, the number of options. N. R represents the number of people, a number of positions that need to be filled. Cool? So I've got 7 positions and I've got 11 people to fill those positions. Happy with that? So my working would go like this, 11p7. Now this is an option on the calculator, but it's important that we know how to do it without the calculator as well. So what was that exclamation mark again?
Factorial.
Factorial. So that would be written as 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2. Am I done?
Yeah.
I am done, but I should have written times 1 as well. Happy with that? Who thinks we're going to be writing that out every single time? Nope, mathematicians are notoriously lazy. There is no way in the world we'll be doing that. What is 11 minus 7? 4. 4 factorial, correct? So we do the minus first, we get 4 factorial. What is 4 factorial? 4 times 3 times 2 times 1. Can anyone see what we can do? Some techniques that we can apply. We can cancel, well I can cancel this 4 with this 4, correct? I can cancel the 3 with the 3, the 2 with the 2, the 1 with the 1, not that I need to. So what am I left with? 11 times 5 or whatever. But again, that's pretty cumbersome and I don't want to have to do this. We're going to pull out our calculators and I'm not going to tell you how to do it. I want you to find it. I want you to find it because the way you become truly proficient with your calculator is that you fiddle and figure stuff out for yourself. So start using some logic. What topics are we dealing with here? What topic are we dealing with? Probability. So I'm looking for something with probability on my calculator. I'm not sure, maybe let's try some buttons. Let's look at the top of my calculator, the first buttons. Options, there, maybe it's one of those. Let's have a look. It'll be in run math. You know it's going to be in run math? So we got to run math. We're probably hitting options. We're probably hitting probability when we do that. We then see all these NC, NPs. Which one do we think it's going to be? NPR. And then it comes up and it's got random numbers. What do I do with those random numbers? Fill them in. What's that answer there? Kim, you've got it? Oh no, you don't, sorry.
1,600,000.
Just give me the numbers and all.
1,663,206.
Okay, so you should get that. Cool. Are we happy with that? So we don't need the box method with our permutations. The box method can be nice and simple for nice small ones, but we can use our permutations. What I want us to do is to check these. Check that my box method is actually the same, because I'm sitting here telling you they're the same. Let's check. So I want us to put in, what would I write if I was to check the first one here?
4P2.
I put 4P2, and I want you to see if that works. No calculator this time. No calculator. We'll check it with the calculator. So what's that going to be? There's an equation. 4 factorial divided by 4 minus 2 factorial. What is 4 factorial? Divided by 2 factorial, which is? What can we do? We get 12. Never ever trust an example with 4 and 2. Because plus, minus, square roots, all sort of things work. So we need to check the next example as well. So let's check the next example. What was the next example? 6p3. We have 6 factorial divided by 6 minus 3 factorial. 6 times 5 times 4 times 3 times 2 times 1 divided by 3 times 2 times 1. Boom, 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 boom. And I get 120. Happy with that? Are we happy that they're the same method?
Yes.
What's the advantage of the permutations? It is easier, it works for everything, correct? I'd argue that that's probably easier than that, correct?
Yes.
But when we're dealing with big examples, there's no way we can do it without it. Awesome. Life is good right now because we're just dealing with permutations, no complexity. It's going to get a little bit more tricky when we have to do with permutations and combinations. But we're going to keep life happy.
Are we doing permutations?
We're going to keep life happy. I want you to exercise 5.1, question 1 to 5, and then revert back to what we're doing.